Okay, let's unpack this. Imagine your business as a massive ship. For decades, it's navigated familiar waters. But suddenly, the currents are moving faster than ever, new routes are opening, and even the very definition of a ship is changing. That's the reality for organizations today, facing unprecedented pressure to transform.
Right.
This isn't just about tweaking the sails. It's about fundamentally overhauling the entire vessel, driven by rapidly evolving technology and, frankly, ever-increasing customer expectations.
Yeah, those expectations are key.
It's a race to stay relevant, to keep up, and for many, honestly, just to survive. The stakes are incredibly high, affecting everything from how a business forecasts its future to how it delivers even a simple customer interaction.
Indeed. Our latest deep dive paints a clear, stark picture. Digital disruption isn't just some, distant concept. It's happening all around us right now. Many organizations, from long-established industries with decades of legacy systems to agile startups, have already begun their journey of digitization.
They had to, right?
Exactly. This process started subtly in the late 20th century and is rapidly accelerating in the 21st, reshaping the very fabric of commerce and, well, daily life. The pace is simply breathtaking, and it demands attention.
Absolutely. And that's why today we're taking a deep dive into a crucial area. The module driving digital transformation through cloud, specifically focusing on the current business challenges organizations are grappling with.
Good place to focus. It's where the rubber meets the road.
Yeah. We'll explore what exactly is pushing businesses to change at this accelerated pace, the specific obstacles and inefficiencies they encounter when they try to adapt.
Right.
And perhaps most importantly, how IT, the literal engine room of these organizations, is evolving to meet these relentless demands with cloud computing positioned right at its core.
Cloud Central.
Our mission, as always, is to extract the most important insights from the material we've gathered to give you a shortcut to being truly well-informed on these critical, transformative issues.
The relentless pressure of digital disruption.
So the first thing our sources make abundantly clear is that digital transformation isn't just an option anymore. It's an unavoidable, mandatory mandate for organizations to transform digitally and at an accelerated pace.
It's not a nice to have.
Not at all. This isn't a strategic choice you get to sit on for a few quarters. It's being forced by modern customer expectations.
Oh, really?
And what's really driving those expectations, it's a perfect storm of new technologies that have fundamentally changed how people interact with services and products in their daily lives.
You just look around, right?
Exactly. Think about how we shop, communicate, or even hail a ride today versus just 10 or 15 years ago. It's a completely different world.
It really is. And it's fascinating to observe the sheer speed of this disruption and how quickly it impacts established players. IDC reports are quite stark on this point.
Oh, yeah.
They indicated that by 2018, which feels like ages ago now, but really isn't, digitally enabled competitors were projected to disrupt a significant 33% of all industry leaders.
Wow, a third. That's huge.
It is. This isn't just about losing a few customers. It's about entirely new business models emerging, often from these, agile startups that can quickly unseat incumbents. It forces a radical reassessment of what business as usual even looks like. If you're not moving, you're falling behind. And falling behind quickly in this landscape can mean becoming irrelevant fast.
And what's truly profound, showing just how deep this shift goes, is that the same IDC report suggested that by 2020, a full 50%, half of the global 2,000 companies, those massive established players we all know, were expected to see the majority of their sales coming from digital products and services.
It's a mind-blowing statistic.
Isn't it? That's not just a trend, that's a fundamental redefinition of what a company sells.
Right.
It means a manufacturing giant might now generate more revenue from, say, software subscriptions tied to its machines than from the machines themselves.
The service becomes the product.
Exactly. That shift forces a complete overhaul of their business model, from research and development to sales, and certainly how they build and manage their IT infrastructure. It changes everything.
So fundamentally, to react to these pressures, organizations are applying software in powerful new ways. It's no longer just a back office tool. Software is becoming the core engine of the business, a central nervous system, if you will.
That analogy.
One key area is in forecasting and opportunity spotting. Modern software is used to estimate future requirements and identify new, often information-based opportunities.
Like seeing around corners. almost.
Sort of, yeah. Imagine how advanced data analytics powered by software can reveal subtle market gaps or predict consumer shifts that traditional methods would completely miss. It allows businesses to be proactive, anticipating changes rather than just reacting to them.
That makes perfect sense. And it's about more than just finding new opportunities. It's about how you deliver value, right?
No.
Take personalized experiences, for example.
Yeah, we see that everywhere.
We see this all the time with consumer companies on our mobile devices. Think about your streaming services suggesting your next binge watch, or online shopping recommendations that seem to know exactly what you want.
Creepy, but effective.
Huh, right. Businesses are now delivering that same level of tailored experience, which isn't just about simple customization. It's about deeply understanding the individual user and proactively meeting their needs, often before they even explicitly state them.
And building on that, software enables agile innovation. This means innovating incrementally, delivering better solutions through small, continuous improvements, rather than waiting for massive, disruptive, big bang releases.
Less risk that way, too.
Much less risk. It's about being able to pivot quickly, test small changes in the market, and iterate based on real-time feedback, greatly reducing the risk associated with large-scale projects. This continuous feedback loop helps ensure that solutions truly meet evolving customer needs, making them much more responsive.
And to really capitalize on these shifts, businesses need to operate in real time. This means taking advantage of rapidly shifting market opportunities the moment they appear.
You snooze, you lose, basically.
Pretty much. The market moves fast, and businesses need to move even faster, making decisions and executing actions in mere seconds, not hours or days. Think about dynamic pricing in ride-sharing apps, or flash sales for e-commerce. These are only possible with real-time software capabilities, allowing businesses to seize fleeting moments.
Finally, in a world where data breaches and cyber threats are, let's face it, increasingly sophisticated, software is vital for demonstrating transparency and trust.
That's a big one. Trust is everything.
It really is. This is a significant challenge in itself, as organizations must not only protect sensitive information, but also prove to the customers and partners that they are doing so. Software-driven security measures, comprehensive audit trails, and robust data governance frameworks become absolutely essential to building and maintaining that crucial trust in the digital age. It's not just about compliance, it's about reputation.
Core business challenges in the digital age.
Okay, moving on from the pressures driving transformation, let's zero in on some of the core business challenges that organizations face in this digital age. The first, and arguably one of the most pervasive, is the sheer data deluge and the demands for real-time processing.
Ah, yes, the data fire hose.
Exactly. The rise of countless applications combined with the explosion of the Internet of Things, or IoT, which, refers to that vast network of physical objects embedded with sensors, software, connecting and exchanging data.
Everything talking to everything else.
Right. It presents significant, often overwhelming challenges for IT organizations.
If we connect this to the bigger picture, you just need to look at your own daily life. Accessing data constantly through numerous activities, from web searches and social networking to emailing, uploading and downloading content, sharing media files, it's become utterly commonplace.
We don't even think about it.
We don't. And it's not just our traditional devices. Internet-enabled smartphones, tablets, wearable gadgets, combined with the ubiquitous presence of IoT sensors and devices, mean we have anytime worldwide data access via virtually any device.
So much data.
The sheer volume of data people generate has increased manifold, truly exponentially.
Yeah.
And the desire isn't just to collect this data, but to process and analyze it in real time or near real time.
Instantly.
Right. This raises a crucial question for organizations. How do you build and maintain systems that can not only handle such an unprecedented influx of data, but also respond to the demand for instant actionable insights? It's like trying to drink from that fire hose. You have all the water, but how do you get just the sip you need precisely when you need it? It requires a complete rethink of infrastructure.
That's a massive challenge, isn't it? Because if you can't manage that data deluge, you certainly can't predict the future or capture those fleeting opportunities, which I imagine is our next big hurdle.
Precisely. This real-time need ties directly into our next challenge: predicting and planning for future business to capture new revenue streams.
Looking ahead.
Yeah. With the daily rise of mobile devices, cloud computing, IoT, and all these other disruptive forces, businesses aren't just adjusting their current models. They fundamentally need to reimagine their future digital organization entirely.
Not just tweak, but reinvent.
Exactly. It's about envisioning new business models, new ways of interacting with customers, and entirely new product lines that might not even exist today.
And it goes beyond just planning, doesn't it? Organizations must be able to establish these new businesses or new aspects of existing businesses as quickly as possible to capitalize on evolving digital marketplaces.
Speed is critical.
This isn't a slow, methodical process anymore. It means developing smarter products and services at an unprecedented pace. The window of opportunity can be incredibly narrow, and if you can't rapidly prototype, launch, and iterate, you risk missing out on valuable market share to a more agile competitor.
And finally, in this mobile-first world, we encounter significant challenges related to governance and risk.
Security and control.
Exactly. The widespread use of tablets and smartphones for accessing organizational data and applications from diverse, often unsecured locations creates a complex web of governance and risk issues.
Your data everywhere.
Pretty much. It's no longer about securing a centralized office with defined perimeters, but about managing data access on personal devices, across public Wi-Fi networks, and even from employees' homes.
That sounds like a nightmare for IT departments accustomed to controlling everything within their own four walls.
It fundamentally shifts the paradigm from traditional desktop-centric management to mobile device management, introducing entirely new complexities in security and compliance.
It changed.
Huge. How do you ensure data integrity and confidentiality when employees are accessing sensitive information from a coffee shop Wi-Fi network on their personal device? How do you enforce corporate policies when the line between personal and professional devices is so blurred? These aren't simple questions, and they demand robust, adaptable solutions that traditional IT was never designed to provide.
Deep dive into traditional IT's obstacles.
Let's peel back another layer and really dive into the deep-seated obstacles that traditional IT departments face. Our sources point to a major culprit, the problem of siloed infrastructure.
Yeah, the silos. Classic IT problem.
Right. Within the traditional data center, each application type typically has its own vertical stack of servers, operating systems, networking, security, and storage resources.
Separate kingdoms.
Totally. Imagine a dozen different applications, each with its own dedicated, isolated set of hardware and software, managed completely separately, often by different teams.
It's almost ironic. These rigid infrastructure silos, which once served individual application needs perfectly, became the very chains binding IT's agility.
Held back.
Yeah. The real insight isn't just their inefficiency, it's how they stifled innovation. These silos hinder resource sharing, often result in higher operating costs because resources are underutilized within each silo.
Makes sense.
And certainly make integrated management a nightmare. Each team has its own tools, its own processes, its own budget.
Chaos.
Basically. The critical question for any organization then becomes, how can IT possibly become a strategic enabler for the business when it's constantly battling the fragmentation of its own internal structure? It's like trying to run a marathon with your shoelaces tied together.
So if IT is tied up battling itself, it can't really innovate for the business. And compounding that problem is the burden of aging facilities and outdated policies.
Old gear, old rules.
Exactly. Many IT departments are literally saddled with physical infrastructure that simply cannot keep pace with modern demands. Existing IT equipment often struggles to support the scalability, security, and performance requirements of what we call third platform applications, the new breed of cloud, mobile, and big data-driven software.
They just weren't built for it.
No, they were built for a different era.
Furthermore, current technologies and the traditional way of thinking may not be able to meet the potential growth of customers, exacerbating the problem of siloed infrastructure.
Makes it worse.
Yeah. If your systems can't scale easily, you just keep adding more individual, isolated stacks, which creates even more silos and pushes you further behind. It's a vicious cycle that drains resources and stifles innovation.
This inability to keep up often gives rise to another significant challenge, the impact of shadow IT.
The rogue departments.
Right. This refers to solutions implemented by departments outside of central IT control. It's not necessarily malicious. It often arises precisely because traditional IT cannot deliver services quickly enough or with the necessary flexibility that individual business units demand.
If you won't give it to me, I'll get it myself.
Pretty much. If the central IT team can't provide a solution fast enough, departments will often find their own, leading to uncontrolled sprawl and potential security or compliance nightmares.
And this leads directly to what we can call the dual demand for IT. In today's digital world, businesses are under immense pressure to develop new applications using agile processes and new tools for rapid time to market.
They want the new shiny stuff.
Exactly. They want the next innovative mobile app, the real-time analytics dashboard. But simultaneously, the business still expects IT to operate and manage the traditional applications that continue to produce substantial revenues.
Got to keep the lights on.
Precisely. Think about core ERP systems or enterprise resource planning systems, which manage day-to-day business activities like accounting, procurement, manufacturing, or financial applications. They might not be sexy, but they are critical.
Can't let those fail.
Absolutely not. This creates a challenging balancing act for IT, pulling them in two very different directions, requiring different skill sets, different processes, and frankly, different mindsets.
The imperative for IT transformation.
Given all these pressures and obstacles, it becomes abundantly clear that IT itself must transform. It's an absolute imperative for organizations to not just survive, but to truly thrive in this new landscape.
No question.
One of the most critical shifts is from being a technology-centric organization to a service-centric one.
Thinking like a business, not just tech support.
Exactly. This means IT should be managed less like a cost center that just procures and maintains hardware, and more like a service business, accountable for its cost, efficiency, and even how it enables revenue generation for the broader organization.
The focus must fundamentally change from merely delivering and managing IT assets, the servers, the storage, the networks, to managing the supply and demand of actual business services.
What does the business actually need?
Right. Meeting business goals now means IT being flexible, responsive, and providing predetermined service levels, often captured in service level agreements, SLAs, that directly align with specific business outcomes. It's about understanding what the business needs to achieve and then delivering IT capabilities as a service to meet those needs, rather than just providing technology.
That makes a lot of sense. So what does this all mean for demonstrating value? IT needs to build products and services that directly support core business objectives.
Things the business cares about.
Yeah, like revenue growth, competitive advantage, customer retention, market share growth, and regulatory compliance. These are the tangible outcomes that customers see value in and are willing to pay for.
It's not just about keeping systems running.
No, it's about enabling growth. Value and accomplishments need to be communicated in terms that truly matter to business executives. This helps build confidence in IT's ability to support broader business objectives. It's about speaking the language of the business, translating technical feats into strategic business wins.
Absolutely. And this transformation is not solely about technology. It critically requires a transformation of IT operations, which is fundamentally about transforming the people and processes that deliver value to the business.
People and process, got it.
IT skills and processes must be modernized to support and truly understand business priorities. This means moving beyond just technical expertise to developing skills in collaboration, agile methodologies, and deep business understanding.
Need broader skills.
Yeah. IT professionals need to become business enablers, not just technology custodians.
The ultimate goal, as we'll explore, is to adopt a cloud model, which necessitates profound changes across people, process, and technology aspects.
All three legs of the stool.
Right. You can't just drop cloud technology into an old structure and expect miracles. Only when these three objectives, modernizing people, processes, and technology in concert, are achieved, can IT truly uncover new cost efficiencies and deliver differentiated business models and capabilities to customers. It's a holistic shift, not just a tech upgrade.
Cloud computing, the core enabler of transformation.
So if transformation is imperative, what's the core enabler?
The big question.
Our sources are clear. To survive in the current business landscape, organizations must transform, and cloud computing is identified as a key enabler for this transformation.
It's central, you said.
It really is. It's not just one tool among many, it's central. Cloud provides crucial business agility, ensuring quick time to market for new services and applications, which directly translates to an improved competitive advantage.
Speed to market.
Yes. If we connect this to the bigger picture, cloud computing is undeniably the most disruptive change enterprise IT has seen in years. It fundamentally alters how IT resources are acquired, managed, and delivered. According to an IDC report, cloud computing has become an integral element, a foundational pillar of any successful digital transformation strategy.
Can't do transformation without it, basically.
Pretty much. You can't really talk about digital transformation today without talking about the cloud.
That's a powerful statement.
Yeah.
And here's where the rubber meets the road, showing the tangible benefits. A recent IDG Research Services study found that organizations aggressively adopting cloud are 3 times more likely than non-adopters to be approaching their digital business and infrastructure readiness goals.
3 times. That's significant.
Isn't it? Think about that. 3 times. That's a compelling incentive to embrace the cloud, indicating a direct correlation between cloud adoption and achieving critical business transformation objectives. It's not just a nice-to-have, it's a competitive differentiator.
And the cloud directly addresses many of the challenges we discussed earlier, providing numerous benefits. For business agility, cloud computing enables quick and anytime provisioning of IT resources.
Spin things up fast.
Exactly. This drastically reduces the deployment time for new applications and services, allowing businesses to respond faster, often in minutes, to market changes, rather than weeks or months. Imagine spinning up new servers in an hour instead of waiting for procurement and installation. That's the kind of speed cloud enables.
And this speed also translates into reduced IT costs.
Big one for the CFO.
Absolutely. With cloud, consumers can rent IT resources on a pay-per-use or subscription basis, which fundamentally changes how organizations spend money on IT.
OpEx versus CapEx.
Right. Operating expense instead of capital expense. It cuts capital expenditure, eliminating the need for large upfront investments in hardware that might sit underutilized. It also reduces ongoing expenses tied to infrastructure configuration, management, physical floor space, power consumption, and cooling, all those hidden costs of a traditional data center.
Then there's high availability. Cloud ensures resource availability at varying levels, often exceeding what individual organizations can achieve on their own.
Keeping things running.
Yep. This is done through redundant components across compute, network paths, and storage and clustered software, enabling fault tolerance even across multiple data centers. This means if one part of the system or even an entire data center fails, your services can continue running with minimal disruption, meeting those critical uptime SLAs, or service level agreements, basically, guarantees for how much time your systems will be up and running.
And think about improved IT management efficiency. Maintenance tasks are significantly reduced as the cloud provider manages the core infrastructure.
Someone else handles the patching.
Exactly. Handling things like software updates, security patches, and hardware renewals. This frees up your internal IT staff to focus on higher value activities, like developing new applications or directly supporting business units rather than constantly keeping the lights on.
Finally, cloud offers unparalleled flexibility of access. Applications and data reside centrally in the cloud, accessible from anywhere via any device, be it a desktop, a mobile phone, or a thin client over a network.
Work from anywhere.
Pretty much. This strongly supports bring your own device, or BYOD, trends, eliminating dependency on specific endpoints. Employees can work securely from anywhere, on any device, boosting productivity and collaboration in ways traditional IT couldn't easily support.
Application transformation as a core response to digital demands.
Okay, building on the power of the cloud, let's talk about a critical outcome it enables: application transformation.
Modernizing the software itself.
Right. In today's economy, software has become a primary competitive weapon. With new software-defined processes, falling costs, and ubiquitous availability, software empowers any business to play offense in the marketplace.
Go on the attack.
Yeah. This means actively seeking new customers, disrupting existing players, and generating entirely new revenue streams that weren't possible before.
Indeed. Digital products can significantly enrich existing portfolios, with new software features complementing traditional product lines, adding immense value for customers.
Like an app for your smart fridge.
Exactly. For example, a physical product might now come with a complementary mobile app that enhances its functionality or user experience. Emerging applications can now process streaming and live data, providing real-time insights that inform critical events as they happen, allowing for immediate, data-driven decisions.
And it extends to how businesses engage with their customers. Software, mobile applications, and personalized workflows enhance customer engagement, leading to higher satisfaction and, critically, better retention.
Keep them coming back.
Right. Think about how a personalized feed or a seamless mobile ordering experience keeps you coming back to your favorite apps. Within the organization, process automation and digitizing workflows significantly increase transparency, boost agility, and drastically reduce waste.
Ultimately, application transformation is the key to unlocking digital business advantage. This ranges from enabling more efficient business operations to driving groundbreaking product and service innovation and achieving faster time to market.
We see examples everywhere.
Oh, yeah. Companies like Tesla, with its ability to update and monitor cars remotely, Uber, which completely disrupted the taxi industry with a software platform, and even General Electric, harnessing in-flight engine data for predictive maintenance. They demonstrate this principle. They all focus relentlessly on compelling user experiences, responsive design, and leveraging data analytics to redefine their industries.
To understand this transformation, it's helpful to look at IDC's 3 platforms of IT growth. This framework shows how computing has evolved based on the scale of users and the scope of applications.
Good framework.
Platform 1 dates back to computing's dawn, based primarily on mainframes and terminals. These supported millions of users and thousands of applications, with mainframes central for mission-critical apps and databases. They were powerful, but, centralized and rigid.
Big iron.
Right. Then came Platform 2, which emerged with the personal computer in the 1980s. This platform was defined by client-server models, relational database management systems. Think of them as highly structured digital filing cabinets for huge amounts of data and early web applications, the PC era.
Yep. It scaled up to support hundreds of millions of users and tens of thousands of applications. Think about the rise of enterprise resource planning, ERP systems, or customer relationship management, CRM tools, running on networked PCs. Both Platform 1 and Platform 2 applications are generally considered traditional in today's context.
And that brings us to Platform 3, the current era.
Where we are now.
Exactly. This platform comprises cloud, big data, mobile, and social technologies. It already supports billions of users and millions of applications, evidenced by over 2.4 billion people connected to the internet. This explosion of connectivity and data is precisely what's forcing the transformation of those traditional applications, pushing them to become more dynamic and scalable.
However, those traditional applications come with significant challenges. They're typically built with a monolithic architecture.
The monolith.
Right, meaning they're developed as tightly coupled code, installed as a single, indivisible package. The problem is, changes to one module often affect others, leading to incredibly long development and update cycles.
Slows everything down.
Massively.
Yeah.
This makes them difficult to maintain and, critically, lacking agility for the demands of digital business. A minor bug fix in one part of the code might require retesting and redeploying the entire massive application, which is incredibly inefficient.
They also often have inherent design limitations. Many were designed for desktop computers first, often requiring separate interfaces for other devices like mobile phones.
One size fits one.
Exactly. This meant building a completely different user experience for each form factor, which is incredibly inefficient. And when it came to scalability and resilience, traditional applications achieved this through what's called vertical scaling, literally making one server bigger.
Scaling up, not out.
Yeah, right. Their resilience relied heavily on highly available infrastructure, with redundant components and automated recovery at the hardware level, rather than the application itself being inherently designed to handle failures.
Development processes for these traditional applications typically used a linear, continuous approach, often referred to as the waterfall model. Development, then build, then test, then deploy, then move to production.
Very sequential.
Very. While suitable for stable systems of record like ERP or financial systems, this approach often led to delays and missed deadlines, and simply wasn't built for the rapid innovation cycles demanded today. These rigid architectures fundamentally impede agility and innovation.
They hold you back.
Definitely. It stacked the infrastructure, middleware, operating systems was planned far in advance, and developers spent more time setting up, configuring, or troubleshooting environments than actually writing new code.
So, the need for application transformation becomes undeniable. Success and growth in today's economy depend entirely on how well an organization embraces digital trends in its interactions with employees, customers, and shareholders.
Gotta keep up.
Every company is becoming a software and data-driven company, where software and data are the weapons of innovation and competitive advantage.
Customers today expect applications to use dynamic social graphs, support seamless mobility, provide personalized workflows, and be highly performant, accessible anywhere, anytime.
Table stakes now.
Pretty much. To meet these demands, organizations are adopting cloud and modern IT infrastructure. This isn't just to reduce IT management costs. It's to meet committed availability, increase scalability for both modern and next-generation applications, and fundamentally respond to changing business needs with speed and flexibility.
When it comes to how organizations actually do this, our sources outline several approaches to application transformation, often referred to as the 6 Rs, though primarily 4 are detailed. The first is rehost, often called lift and shift.
The simplest one.
Right. This means moving applications to cloud infrastructure without any changes to the code or architecture. It's the simplest path, getting you into the cloud quickly, but it doesn't immediately modernize the application itself. Think of it like moving your furniture from one house to another without renovating it.
Then there's refactor, which is more involved. This means re-architecting an application to truly leverage cloud-native features.
Making it fit the cloud.
Exactly. A classic example is converting large monolithic applications into smaller, independent microservices, making them ready for containers and a DevOps approach. This allows for greater agility and scalability within the cloud environment. This is like renovating your furniture to fit the new house better and be more functional.
Next up is revise. This approach enriches existing applications by adding new modules and features using cloud capabilities while making minimal changes to the core legacy code.
Adding on top.
Yeah. The application becomes a hybrid of old and new components, communicating seamlessly via standard protocols like HTTP, REST, or AMQP, Advanced Message Queuing Protocol. It's about extending the life and capabilities of existing systems without a full rewrite. You keep the old, but add new connected additions.
The fourth key approach is retain. This applies to certain traditional application workloads that are still useful to the business but simply not suitable for the cloud.
Some things stay put.
Right. For example, native applications with proprietary architectures or very legacy code might be difficult or cost-prohibitive to move or refactor. These workloads continue to run in their existing environments, benefiting from ongoing improvements in data center infrastructures, but not directly migrating to the cloud.
So what do these transformed applications look like? They possess several key characteristics of modern applications. Perhaps the most critical is speed.
Need for speed.
Always. They're designed to deliver services in hours, not weeks or months, which is absolutely essential for digital business where time to market is everything. Another crucial characteristic is that they're designed for failure.
Expecting things to break.
Yeah, kind of counterintuitive, but vital. They expect components to fail and are built to adapt on their own. They support predictive and reactive scaling algorithms, using live performance measures to dynamically scale resources up or down as needed automatically. This means if one part breaks, the whole system doesn't collapse. It simply routes around the problem or spins up a new instance.
Building on that, modern applications are also inherently modular. This reduces long-term technology commitments because it's much easier to replace individual modules in a modern application without affecting the entire system.
Like Lego bricks.
Exactly like Lego bricks, you can swap out one piece without rebuilding the whole structure. And finally, these applications prioritize resilience and scalability. They continue to operate despite component failures, like a network outage. They assume that software components will fail and are designed to adapt and recover in real time, handling load elastically.
So they stretch and bounce back.
Pretty much. This means they can scale resources, both software and hardware, without any user-detectable degradation, being elastic for user load and failure recovery. Their architectures are also API-enabled for dynamic ecosystem connections, allowing them to easily integrate with other services and platforms.
Now, let's look at one of the most distinctive modern architectures that embodies these characteristics. Microservices architecture.
The buzzword, but an important one.
Definitely. This is a method where applications are decomposed into small, loosely coupled, independently operating services.
Breaking the monolith apart.
Right. Each microservice runs in its own process, communicates via lightweight REST APIs, representational state transfer application programming interfaces, and can be deployed, upgraded, scaled, and restarted completely independent of other services.
When managed by automated systems, this enables frequent updates to live applications without negatively impacting users. The benefits are significant. It speeds up deployments, facilitating continuous integration and continuous delivery.
Faster changes.
Much faster. It drastically improves fault isolation. If there's a memory leak in one tiny service, only that particular service is affected, not the entire application.
Limits the blast radius.
Good way to put it. And it allows for independent development and deployment by different teams, breaking down those traditional silos we discussed earlier and eliminating long-term commitment to a single, rigid technology stack.
We even have a great case study for this. Imagine a large entertainment company, a major player in streaming media and DVD by mail.
I think I know who you mean.
Probably. They struggled immensely with expanding their on-premises monolithic infrastructure. They were quickly overwhelmed by increasing customer demand and branching out to new platforms like Xbox, Wii, and mobile devices, along with global expansion. Thousands of server instances needed to be commissioned simultaneously to meet demand, but their monolithic application couldn't scale different components at different rates. Everything scaled together or not at all.
Yeah, that's a classic monolith problem.
So they made the pivotal decision to shift their applications into the cloud and adopt a microservices architecture. This allowed them to focus on application functionality instead of constant operational maintenance.
Huge strategic move.
Massive. The transition meant moving from one traditional development model, producing a single monolithic DVD rental application, to a microservices architecture supported by many small, independent teams. These teams became responsible for developing hundreds of microservices that work together to stream digital entertainment to millions of customers every day.
Hundreds of services.
Oh, wow. The primary reasons for this monumental move were simple: to achieve 2057 availability, scale to the next order of magnitude, and optimize for speed.
The core cloud benefits.
Exactly. The microservices architecture allowed them to greatly speed up development and deployment, build and test global services without impacting the current system, and quickly roll back if problems arose. Crucially, it allowed them to create independent engineering teams with different release schedules, which significantly increased agility and productivity across the organization.
Hand in hand with microservices are containers.
Docker and the like.
Right. These are lightweight, standalone executable packages containing the whole runtime environment, the application, its libraries, binaries, and configuration files. They run on a host system, sharing its operating system kernel, but with resource limits for processor and memory, ensuring one container doesn't consume all host resources.
Lighter than VMs.
Much lighter. The key here is that they are far more lightweight and use fewer resources than traditional virtual machines. Think of them like perfectly packed shipping containers. Everything the application needs is inside, and it can be moved anywhere.
This leads to much greater modularity. Instead of running a whole application in one container, it can be split into microservices, with each microservice instantiated only when needed and becoming available almost immediately.
Efficient.
Very. The concept gained widespread importance with Docker, an open-source tool that gave containers much better portability without requiring any code changes. They can run practically anywhere, enabling seamless horizontal and vertical scaling between private and public clouds.
And that portability is key.
It fundamentally changes the way we think about deploying and managing applications, moving us from managing entire servers to managing discrete, portable application components.
Beyond the technical architecture, transforming applications also requires embracing lean practices.
Cutting the fat.
Essentially, yeah. The goal here is clear. Create high-quality software in the shortest possible time at the lowest cost.
Yeah.
This means creating more value for customers with fewer resources. It's a relentless focus on understanding what truly delivers customer value and continuously improving the key processes that deliver it.
Less waste, more value.
Exactly. Our sources highlight that traditional waterfall development often leads to cost overruns and delays, while an agile model is more adaptive, iterative, and delivers limited features per cycle, ensuring key features are built and proven viable first.
And finally, a cornerstone of this transformation is DevOps culture and automation.
Breaking down the wall between dev and ops.
Right. As you heard earlier, delivering applications quickly and effectively is the only way to stay competitive in this ever-changing digital world. DevOps is a methodology where software developers and IT operations staff collaborate intensely, breaking down the traditional silos between them.
And the benefits are undeniable, backed by studies. A Puppet study involving 4,600 IT professionals observed incredible gains. Companies with strong DevOps practices experienced 24 times faster recovery from failures.
24 times?
Due to increased efficiencies, standardization, and a unified culture that actively works towards common goals. They also achieve 200 times more frequent deployments because of standardized processes and extensive automation, overcoming those siloed cultures that typically slow everything down.
Wow, those numbers are staggering.
They really are. This means companies with DevOps can focus more on developing new applications because manual, error-prone processes are eliminated, significantly boosting developer productivity. Instead of constantly keeping the lights on and fixing recurring issues, their teams are free to innovate.
Within DevOps, two crucial practices are continuous integration, CI, and continuous delivery, CD.
CI/CD pipeline.
Yep. With CI, developers merge their code changes to the main source branch frequently, often multiple times a day. A CI server automatically checks out the main branch and runs automated integration tests against these new changes, providing early feedback to ensure updates haven't broken anything. It relies heavily on automated testing to catch issues quickly.
Continuous delivery, CD, extends CI by adding a fully automated suite of tests, including acceptance tests and an automated deployment pipeline. This ensures rapid, reliable, low-risk software delivery at any time, often with zero downtime.
Always ready to deploy.
Exactly. Developers push code, which is automatically built, tested, versioned, and then made on demand for deployment. It's about being ready to deploy to production at any given moment.
The impact of these techniques is profound. They can reduce delivery time from weeks to mere hours, allowing developers to focus on coding valuable features and quickly integrate user feedback.
Which keeps you competitive.
Absolutely. This helps businesses stay ahead of the competition and significantly increases customer satisfaction because they're getting new, improved features faster and more reliably.
Modernizing service
And
management.
beyond application development, the very way IT manages its services needs a fundamental overhaul.
How IT delivers value.
Right. Let's look at the challenges of traditional service management. Our sources highlight that traditional IT departments are often deeply siloed, leading to inherent inflexibility and inefficiency. Different teams for networking, storage, servers, each with its own processes and tools.
Those silos again?
They keep popping up. This siloing often leads to delayed service requests. Even for basic services, new IT service requests are delayed due to multiple submissions and coordination required across these different silos.
Waiting forever for a simple request.
It happens all the time. The process for provisioning a new server, for example, might involve tickets being passed from one team to another, then back, leading to incredibly slow time to market. Additionally, IT departments are frequently bogged down by manual activities like virtual machine provisioning, configuration, change requests, and incident resolution.
Repetitive tasks done by hand.
Yeah, these are repeatable, yet often handled by hand, which introduces errors and slows everything down.
What's more, traditional management processes and tools are often inadequate. They simply do not support a modern, service-oriented infrastructure, especially when it comes to on-demand provisioning, rapid elasticity, and maintaining sustained service levels in a dynamic environment.
The tools don't fit the new model.
Right. If these tools do enable some service management, they're often implemented separately from service planning and design, leading to critical gaps in monitoring and overall management.
These challenges highlight the critical need for service automation. Speed is paramount for today's businesses. Windows of market opportunity open and close quickly. IT organizations must transform their operating model to make IT services easier for the business to consume and for IT to manage efficiently.
Automation is key.
It really is. Service automation directly overcomes these provisioning and management challenges to achieve crucial business agility.
This involves deploying tools that enable self-service requests via portals and catalogs, allowing business users to get what they need with minimal IT intervention.
Ordering IT like you order from Amazon?
Kind of, yeah. It also means automating IT operations and service delivery, encompassing automated operations management and orchestrated service delivery processes. The goal is clear. Any predictable, repeatable manual process should be eliminated via automation.
Consider this example. A business user needs IT resources for a new project. Traditionally, they raise a ticket, and IT tracks a long, complicated process involving multiple approvals and manual configurations across different teams.
The old way.
Right. With automation, the user makes a request via a self-service portal, and then orchestration and automation software instantly provisions the necessary components across the cloud infrastructure based on that request, often in minutes. It completely changes the user experience and the IT workload.
And this brings us to the power of orchestration.
Making the automation work together.
Right. Orchestration is the automated arrangement, coordination, and management of various system or component functions within a cloud infrastructure. Its purpose is to provide and manage cloud services programmatically. Cloud service providers deploy purpose-designed orchestration software, often called orchestrators, that programmatically integrate and sequence system functions into automated workflows for higher-level service provisioning and management.
What's fascinating here is that these orchestration workflows aren't just for fulfilling consumer requests like spinning up a new virtual machine. They're also vital for administering the cloud infrastructure itself, like automatically adding resources to a resource pool when demand dictates.
So it manages the cloud, too.
Exactly. This fundamentally changes the role of IT administrators, doesn't it? Instead of performing manual tasks, they become designers and managers of these automated workflows, focusing on policy and optimization rather than repetitive actions. They're moving from being operators to architects.
That's a huge shift in skill sets and responsibilities. And how do these orchestrators talk to all the different systems?
They commonly interact with other software components and devices using application programming interfaces, or APIs.
APIs again?
They're everywhere. These are essentially source code interfaces that allow different software programs to communicate and interact programmatically, enabling seamless automation. Think of APIs like standardized menus in a restaurant. Instead of going into the kitchen to prepare your food, you just tell the waiter what you want from the menu and the kitchen prepares it. APIs allow different software programs to order information or services from each other.
Good analogy.
Our sources outline several key workflow elements that make up these automated processes. You have actions, which are predefined scripts executed by the orchestrator, manual interaction, which prompts a user for input with definable timeouts, and conditions, which are conditional branches that take input parameters and return true or false, allowing workflows to branch into different directions.
Decision points.
Right. Other elements include waiting time event, which pauses workflow execution for a specified period or until a specific event occurs. Child workflows, meaning workflows can be hierarchical and contain nested workflows for modularity. And finally, an endpoint, which signifies the completion of a workflow.
To make this concrete, let's walk through an example workflow for a virtual machine request, building on what you mentioned earlier.
Okay.
Imagine a consumer requests a new VM via a cloud portal. That initial service request immediately creates a change request in the system.
Got it.
The orchestrator then triggers a change approval and execution workflow. This workflow first determines if a change advisory board, CAB review, is needed based on predefined policies.
Skip the CAB if possible.
Right. If it's pre-approved or exempted, it bypasses the CAB. If not, it goes to the CAB for review. If approved, or if it's pre-approved, a resource provisioning request is automatically sent to a unified manager.
The central controller.
Exactly. This unified manager then coordinates to provision the necessary compute, storage, and network resources across the cloud infrastructure, all automatically based on that initial user request. It's a huge shift from the manual ticket-based approach.
Night and day difference in speed and efficiency.
Navigating cloud security challenges.
As we embrace these transformations, a critical discussion point, and frankly a major hurdle for many organizations, is navigating cloud security challenges.
Always a top concern.
Definitely. Information security is critical for both businesses and individual users, whether it's protecting bank account details, intellectual property, trade secrets, or personal files. This information can be incredibly hard to recover if lost, and unauthorized access can be profoundly dangerous.
This isn't just theoretical. The costs are staggering. The Ponemon Institute's 2017 study reported the global average cost of a data breach at $3.62 million, with each lost or stolen record costing $141.
Ouch. Per record.
Yeah, and we've all heard of real-world examples like the WannaCry attack in May 2017, which encrypted systems worldwide and demanded ransom, disrupting critical services globally.
I remember that one.
Beyond the financial costs, security breaches can also lead to the stealing of innovative ideas, intellectual property information, and product designs and prototypes, crippling a company's competitive edge. This raises a crucial question for any organization. How do you prioritize security from the outset, integrating it into the architecture and design phase, rather than treating it as an afterthought?
Build it in, don't bolt it on.
Exactly. Because if you bolt security on at the end, it's never as effective.
That's a fundamental shift in mindset.
Yeah.
Cloud computing's unique features create new security challenges, especially concerning trust due to customers' varying degrees of control and visibility over their data. This is where the shared responsibility model comes in.
Ah, yes, the line in the sand.
Right. Security is a shared responsibility between cloud providers and consumers. Providers secure the cloud, meaning they're responsible for the underlying infrastructure itself, the physical security of data centers, the network, the virtualization layer.
Foundation.
While consumers are responsible for security in the cloud, meaning their data, applications, operating systems, and network configurations within the cloud environment.
What you put on top.
Exactly.
This is a fundamental difference from traditional data centers where you controlled everything. Firewalls alone are insufficient in the cloud. Extra mechanisms like VPNs, virtual private networks, and intrusion detection and prevention systems, IDPS, are needed.
Need more layers.
Yep. The rapid elasticity of the cloud means security tools must detect and secure newly provisioned resources instantly. Resource pooling and multi-tenancy, where multiple customers share the same underlying hardware, increase the need for robust logical isolation and strong access controls to prevent one customer's breach from affecting others.
Can't let your neighbor's problems become yours.
Precisely. Despite these differences, fundamental security requirements like confidentiality, integrity, availability, and accountability still apply to both cloud and non-cloud environments. The basics don't change.
Now let's get into some of the key cloud security threats specifically called out in our sources. First up, data breach.
The big one.
Unauthorized access to confidential data caused by things like compromised passwords, poor application design, poor network segregation, weak encryption, or even malicious insiders.
Lots of ways in.
To mitigate this, organizations should implement multi-factor authentication, strong encryption, and tightened network security. For instance, a leading financial organization experienced a massive data breach due to a vulnerability in third-party software, exposing millions of customer names, social security numbers, and addresses. This happened despite a patch being available, highlighting the critical need for timely updates.
Patching matters. Next is identity, credentials, and access management, IAM. The challenge here is managing identities and access permissions for millions of users across diverse cloud services.
Who gets access to what?
Right. Credentials and cryptographic keys must be rotated periodically, strong passwords must be enforced, and multi-factor authentication, MFA, is highly recommended for both providers and consumers to prevent password theft. For example, a multinational e-commerce company reported a cyber attack where hackers gained access to their network using corporate employee credentials, exposing millions of usernames, addresses, and other personal data. The company had to ask customers to change their passwords, underscoring the vital importance of robust IAM.
Then there are application programming interface, API vulnerabilities. APIs are used extensively for nearly all cloud activities, provisioning, configuration, monitoring, and management.
The glue holding it together.
Exactly. Vulnerabilities in these APIs can lead to breaches of infrastructure. Mitigation requires designing and developing APIs following security best practices, including robust authentication, authorization, encryption, and avoiding common coding flaws like buffer overflows. Access to these APIs must also be strictly restricted to authorized users. An example given is a mobile application development company that was affected by API vulnerabilities in their back-end systems, which exposed customer information.
We also face system and application vulnerabilities, which are exploitable bugs in programs that hackers can use to compromise system security. Cloud computing's multi-tenancy and resource pooling expand the attack surface for these vulnerabilities.
More places to attack.
Right. Mitigation includes installing security patches, performing regular vulnerability scanning, and preventing applications from gaining unauthorized access to entire file systems or other applications on the disk. A film entertainment company, for instance, reported a cyber attack that exploited a zero-day vulnerability, an undisclosed bug that hackers used before developers had time to fix it to gain access to their network.
A very real threat is account hijacking. This is when an attacker gains access to cloud consumer accounts, often through phishing or by installing keystroke logging malware.
Stealing your keys to the kingdom.
Pretty much. The impact is huge in shared cloud environments, as hijacked accounts can be used to modify information, redirect users to illegitimate sites, or launch further attacks. Multi-factor authentication and a defense-in-depth approach, which means layering multiple security measures, are crucial for mitigation. We saw a high-profile example where many social media accounts, including those of CEOs and politicians, were hijacked and used to post false messages, though they were quickly recovered.
Another significant threat comes from malicious insiders, current or former employees, contractors, or business partners who misuse their authorized access.
The enemy within.
It happens. An IBM report from 2015 indicated that insiders were responsible for 60% of attacks, far more than outsiders.
Wow, 60%.
Yeah. Mitigation includes strict access control policies, immediate account disablement post-separation, regular security audits, encryption, and segregation of duties, meaning no single person has too much control.
Next, advanced persistent threats, APTs, are stealthy, long-term attacks designed to steal data.
The spies.
Right. They typically involve phases like gaining initial access, often via spear phishing, a targeted email attack, moving laterally across the network, installing malware, adapting to defenses, and harvesting information over an extended period.
Low and slow.
Exactly. Traditional antivirus software is often insufficient. Real-time monitoring for late logins, backdoor Trojans, and unexpected data flow, along with employee awareness programs, are essential. An independent civil service agency for a government, for instance, discovered an APT that exposed PII, personally identifiable information, including fingerprints, of millions of government employees over several months.
Data loss can occur for reasons other than malicious attacks, such as accidental deletion by the provider or destruction from natural disasters. Cloud providers are typically responsible for such losses, and mitigation involves robust data backup strategies and clear protection mechanisms published in service contracts.
Gotta have backups.
Always.
Then there's abuse of cloud services. Cybercriminals exploit cloud advantages like free trials or extensive computing resources to launch malicious activities such as DDoS, distributed denial of service attacks, hosting malicious websites, or conducting phishing campaigns.
Using the cloud's power for evil.
Right. For example, an attacker might crack an encryption key in minutes using cloud resources that would take years on a personal computer. Mitigation involves strict acceptable use policies and strong incident response teams. Attackers once misused a cloud storage service to infect systems with malware via a massive spear phishing campaign, hosting fake login pages on the provider's own infrastructure.
And of course, denial of service, DOS, and distributed DDoS attacks. These aim to exhaust key resources like network bandwidth or CPU cycles, preventing legitimate users from accessing services.
Flooding the gates.
Exactly. In a pay-per-use cloud environment, this can incur non-productive expenses for the consumer if they are charged for the resources consumed by the attack. Mitigation involves resource consumption restrictions, disabling unused ports, applying security patches, and deploying firewalls. A commercial news and information broadcast company, for example, suffered a major outage on New Year's Eve due to a DDoS attack, which reportedly utilized cloud services.
Finally, we have shared technology issues. In a multi-tenant cloud environment, the failure of mechanisms that ensure the separation of resources like memory or storage can expose one consumer's data to another, creating significant security risks.
Leaks between tenants.
Right. Compromising a hypervisor, the software that creates and runs virtual machines, is a particularly high-risk event because it can expose the entire environment. Mitigation includes hardening the hypervisor, operating systems, and virtual machines, as well as implementing strong logical isolation using technologies like VLANs, virtual local area networks. It's a constant battle to secure this complex, dynamic environment.
Constant vigilance.
Yeah.
Outro.
So we've unpacked the driving forces behind digital transformation and the profound business and IT challenges that come with it. From the overwhelming data overload and the complexities of managing antiquated, siloed legacy systems to the ever-present and evolving threats in the security landscape, it's clear that businesses today are navigating truly turbulent waters.
And through this deep dive, we've clearly seen how cloud computing isn't just a technology trend.
Yeah.
It's a fundamental enabler that helps organizations address these challenges head-on. It offers unparalleled business agility, significant cost reduction, and provides the very foundation for modern application development and agile service delivery that are essential for today's competitive landscape. This transformation isn't just about shifting technology. It's truly about the holistic evolution of people, processes, and technology working in harmony.
Ultimately, embracing the cloud allows businesses to fundamentally reimagine their operations, innovate at a much faster pace, and meet the dynamic, increasingly high expectations of today's customers. It's about building a resilient, responsive, and secure future that can withstand disruption and seize new opportunities.
As we conclude this deep dive, consider this provocative thought for your own exploration. Given the continuous evolution of technology and the escalating complexity of challenges we've discussed, what emerging digital trend or even societal shift do you foresee becoming the next major current business challenge that organizations will need to overcome in their ongoing digital transformation journey?
Good question.
And how might cloud computing, itself constantly evolving, be redefined to meet it?